Okay, so we're starting here in section 2A, working with units. As I mentioned before in the introductory video, I'm not going to, when I go through these video lessons, they're not going to be me working through every single problem in the notes, because in Blackboard I have available to you this blank set of notes, a worked out solution key, as well as this video. In the video, what I like to do is try to tackle for sure the harder problems that folks tend to make some mistakes on, so I make sure that you get some verbal instruction on how to do that, and you can see that. And then I also just in general need to show you just specific steps on how to solve certain problems. But for example, in some of the notes, I'll have two problems that are basically the exact same. If I do one, then it's a good point in the video for you to stop it, pause it, and you try the second one and compare it with the solution key. So my advice to you whenever you sit down to work through these notes is to go into Blackboard and actually physically print off the blank set of notes that you see here in front of you, as well as that solution key set of notes that's fully worked out and shows all of the steps. That way, as you're working through the notes and watching the video, whenever it's a good time to pause it, you have the other piece sitting there in front of you so that you can immediately check yourself. It also gives you the opportunity at that point that if you got that next one wrong, that you might want to say, hey, you know what, I might need to rewind this a little bit and listen to her say that again, and get a better feel for the material itself. So just an overall disclaimer, again, I'm not going to work through every single problem, but I believe that what I do try to do is to give you a good foundation that once you work through the video here, that you should be able to then use what you've learned in the video along with seeing what's on the solution key to point you in the right direction for the material. Okay, so moving on then, the first two questions here on the notes, you'll be able to pick that up easily from the from the solution key. So I'm just going to move into the keywords and operations that are associated with particular units. And the first one that you see here is the word per. And the word per is indicative of, it's telling you to divide. Of, or a hyphen, means to multiply. Squaring means that you're raising something to the second power. And cubing means that you're raising something to the third power. All of these are elements that we will be using throughout this section and even moving forward in the rest of this unit. Okay, so I'm going to move on down and I'm going to do example 1. And as you notice me work through some of these examples, especially here in these first few, some folks will say, well, hey, I knew how to get this price and all I had to do was multiply, or all I had to do was divide. I don't know why you showed all of this work. I'm showing this work because as you know, many things start out sometimes very easy and maybe for some to be quite trivial, but as you work through a set of material, it starts to gradually get more difficult. And so if I show you this setup for some of the easier problems, I want you to be able then, hopefully, that when you get to a harder problem and you say, I don't know how to do this one, that you can use this exact same setup, and that will make tackling that harder problem much easier. All right, so with that said, looking at number 1, it's saying find the total price that you would pay if you were to buy 20 apples at a price of $2 per apple. Let's go back and sort of analyze this. It's saying find the total price. So my cue there is then that I am trying to find, my final answer should be in money, because it's saying find a total price. And what we know here is that we are starting with 20 apples, and the price per apple is $2. So start with what you're given. You've got 20 apples. If you aren't given a fraction, always make it a fraction by putting it over 1. You'll notice that these setups that I'm creating here are very similar to perhaps if you've ever taken a chemistry class. I use the unit cancellation process that you would have seen in a chemistry class, for example. Or if you haven't seen the unit cancellation in a chemistry class, you may would have seen it whenever you've tried to cancel out with fractions before. But again, I'm starting here with my 20 apples. It wasn't a fraction, so I made it a fraction by putting it over 1. I want to get rid of apples because I'm trying to get to a price. And here's where you hopefully might remember from the idea of canceling, is the idea of reducing fractions, is that when items are diagonal from one another, it allows you to cancel out. So since I want apples to go away and end up with just money, I can use this conversion factor that was given to me here in the problem. And since I want to get rid of those apples and apples are up top, in order for that to cancel out, I have to put apples on the bottom. And I can put money up top. This conversion factor says that every one apple costs $2. So up here with the money, I'm putting the $2, and every one apple costs $2. That way now, when we look at this, my apples are diagonal from one another, so they cancel out. The only unit I have left now is money. So these are, you just treat these like fractions. You just multiply straight across. 20 times 2, of course, is 40. And on the bottom, 1 times 1 is just 1, and 40 divided by 1 is just 40. And we know that our unit, the only one we had left, was the money. So $40. So if you were to buy 20 apples at a price of $2 per apple, it was going to cost you 40 bucks. Okay, that's the idea there. Let's scoot on down to, and so this might be a good place to pause the video. You try example 2, okay? What I think I'm going to do now is I'm going to work through example 3 and 4, okay? So looking at example 3, it says, how many crates do you need to hold 2,000 apples if each crate holds 40 apples? So again, I'm going to start with what I have, 2,000 apples. Just going to abbreviate there for the apples. It's not a fraction, so I'm going to make it a fraction by putting it over 1. Notice in this problem, it wants to know how many crates. So I need to be able to get rid of these apples again, and my final answer needs to be crates. So in order to get rid of apples, since apples are up top, I have to put apples on the bottom. They always have to be, units have to be diagonal in order to cancel out. If they're side by side, they're not going to cancel out. So apples are on the bottom, and it tells us here in the problem, each crate, so every one crate, holds 40 apples. So I can go directly from crates to apples. So every one crate holds 40 apples. Okay. At that point then, that allows the apples to cancel out. The only unit I'm left with are crates. That's what I wanted to end up with. So I know that I can stop my conversion factor here, and I'm just ready to multiply across. So of course 2,000 times 1 is 2,000. Up top, or I'm sorry, on the bottom, 1 times 40 is 40. And then just throw in your calculator, 2,000 divided by 40, which will just give you 50. And then our unit there is crates. You want to go ahead and train yourself to get in the habit of writing your units beside your answers, because that's part of the point of this particular unit itself, is to have units. Okay, so go ahead and do that. I do take off a half a point for missing units. Okay, all right, we'll look on down at example 4. It tells you here you've got a room that's 10 feet by 12 feet, and they want us to find the area of the room. And then they also ask us, well, what are the units of, on this particular amount? So if you've got a room that's 10 by 12, then obviously you're talking about a rectangle. So hopefully you recall the area of a rectangle is length times width. So it doesn't matter which one you refer to as the length and width. So I'm just going to use it in the order that they gave it to me here. So I would have 10 feet times 12 feet. And then technically I didn't have to write those units there, but I'm specifically doing it just because I want to be able to show you where my units came from. So, you know, you can throw in your calculator, or hopefully you might know this one off the top of your head. 10 times 12, it's just 120. And then how do I know my units? Anytime you take feet and multiply it times feet, they don't cancel out. They're side by side. So feet times feet, square feet. And if you think about it, if you ever go house shopping or apartment shopping or something like that, you're trying to figure out a lot of times they provide you with what is the square footage, because you possibly don't want to buy something that's or rent something that's too small or too large. You want something that sort of fits your needs. So area is always measured in square units. It might be square feet, square inches, square yards, square miles, but area is always square units. So raising it to the second power. Volume, on the other hand, are always cubic units, so they'll be raised to the third power. So I'll just write that out for you. Area, anytime they ask you area, your units will always be square units. So as I mentioned, I don't know what that is, go away. Square feet, square miles, square inches, etc. Volume are always cubic units. So cubic feet, cubic inches, cubic yards, etc., raising it to the third power, as I mentioned above in the table. Okay. All right, so I'll let you try example 5. This is a good place to pause the video and do example 5. That problem is asking you about how much sand the box can hold. So that is filling something. That's referring to volume. So in example 5, you're going to be doing volume. And so that's going to then entail giving you cubic units. Okay. All right. So before I get down here to example 1, I want to take a moment and look at the conversion sheet that I provided for you in Blackboard. So in this conversion sheet, oh my, right here we go, sorry. All right, so you're going to hear me say in the video direct conversions versus having to do a chain of conversions. What I mean by a direct conversion is that if I ask you to go from inches to feet, you can clearly see right up here at the top that I can go directly from inches to feet, no problem. If I wanted you to go from feet to miles, you can do that directly, okay? So if you're going to convert from feet to miles, then wherever you have the feet in your problem, the 5280 is going to be beside it. Wherever you have the miles in your problem, the 1 is going to be beside it, okay? Here's what I mean whenever I say you can't go there directly. Suppose I wanted you to take ounces and convert that to a gallon. If you look on this sheet, I can take ounces to a cup and I can take ounces to a pound, but if you move on down the sheet here, you'll see that there are nowhere on here where I take ounces to a gallon. So this is where you're going to see me in a few moments in the notes do what I refer to as a chain of conversions, where we can't go there directly, but we'll use a chain that I'm going to take you from ounces to cups, cups to pints, pints to quarts, and then ultimately a quart to a gallon. So it's going to be a four-step chain there. Chains can be small, they can be larger. So it just depends on where you start from and where you have to go. Okay, so that's a little bit of foreshadowing. Of course, we'll tackle that in a little bit more detail in just a moment. All right, so looking on down then, back on the front page, and we are at example 1 below. It says you're traveling in Australia, and the road sign that says that Sydney is 24 kilometers away. And they want to know, they're asking us here, well, how far is this distance in miles? So we start with our 24 kilometers. It's not a fraction, so I'm going to make it a fraction by putting it over 1. And then I go back and I look on that sheet and I ask myself, can I convert directly from kilometers to miles? And this is going to take some of you a little bit of getting used to, that you're going to have to ask yourself, okay, where is it on the sheet itself? So going back to the sheet itself, I'm sorry. Back to the sheet itself, it's actually down here at the bottom that if I'm going to convert from kilometers to miles, sometimes the computer's a little temperamental, so always bear with me. I'm looking at this second row here. It tells you that 1 mile is equivalent to 1.6093 kilometers. So when I do my conversion factor here in just a second, wherever the kilometers end up, 1.6093 has to go where that is, whether it's on the top or the bottom. Wherever the miles end up, that's where the 1 has to go. Either if miles are up top, then the 1's going to be on top. If miles are on the bottom, then 1's going to be on the bottom. Likewise with that kilometers. So these numbers are specifically attached to these labels. That's why it's going to be really important that you write these labels as you do your conversions. All right, so let's go back to this problem. Okay, so I've got 24 kilometers over 1. As I mentioned before, since I want to get rid of those kilometers, I put kilometers on the bottom. And as we just saw on the conversion sheet, I can go directly from kilometers to miles. So I put those miles up top. And then as I mentioned to you, that 1.6093 is associated with the kilometers. So since kilometers are on the bottom, the 1.6093 goes on the bottom. The 1 is associated with the mile, so the 1 goes up top with the mile. Now, here's how you're going to know that you can stop, because my kilometers at that point are diagonal, so they can cancel out. My final answer is supposed to be in miles, and you'll notice the only unit I have left is miles. So, therefore, I can stop, multiply straight across, 24 times 1 up top, just gives us 24. 1 times the 1.6093 on the bottom just gives us the 1.6093. Then you're going to throw that in your calculator, so 24 divided by 1.6093 gives you 14.913. I'm just going to take it out a little bit further because I want to talk just a minute about rounding. This problem tells you here to round to the nearest tenth. The tenths place is the first number after the decimal, and then you look to the number behind that to tell you what to do. If this number behind it is 5 or more, you round up. Since our number back here is a 1, that tells me to keep my 9. So my final answer here then would be 14.9 miles. Final answer. Okay. So I'm going to scoot on over to the next page and look at example 2, I believe. Yeah, I think that's a good one just to kind of reiterate what I was just doing. So I'm going to look at example 2 with you. All right, so in example 2, it says the average adult elephant weighs 7,000 kilograms, and they want to figure out the elephant's weight in pounds. So if you're looking at your conversion sheet, you'll notice that up in the second table, you can go from, let's see, we are going from kilograms to pounds. So actually, it's not going to be up there. It's actually going to be down at the bottom. So looking down at the bottom of your sheet, let me draw that to your attention so you can see it. These two up here, that I do have pounds, but that's pounds to ounces. So let me see if I can, and I have here, that's pounds, but that's pounds to tons, so that doesn't quite work. But if I scoot on down and keep the whole page in mind, down here at the bottom, I do have a conversion that will take me directly from pounds to kilograms. So that's the one I want to use. This time, wherever I put pounds, 2.205 is going to be with it. Wherever I have kilograms, 1 is going to be with it. So getting back to our notes. Sorry. All right. So I start with what I'm given, my 7,000 kilograms over 1. And then if I want to go from kilograms to pounds, it says I can. So to get rid of those kilograms, I put kilograms on the bottom, pounds up top. And as you saw, the 2.205 is associated with pounds. Since pounds are up top, the 2.205 is going to be up top for every 1 kilogram. At that point, kilograms cancel out. I can multiply straight across here. 7,000 times 2.205 should give you 15,435. And then on the bottom, you have 1 times 1, which is just 1. So any number divided by 1 is just itself. So this means then that a 7,000 kilogram elephant, really you're looking at a little or well over 15,000 pounds. And that would be your final answer. Okay. So hopefully you're starting to see the reason why I've been taking the time to show these units, that there's a little bit more, you're gonna be stepping it up, okay? So I think it's a good opportunity here for you to pause and try example 3. I'm gonna scoot on down to example 4 though. All right, so looking at example 4, it asks us how many seconds are there in 1 week. So I start with what I'm given, my 1 week. You may already be saying, well, I don't have any time conversions on my sheet, and you don't. We take for granted that everybody should know that there are 7 days in a week, 24 hours in a day, 60 seconds in a minute, and so on. So basic time conversions we did not put on the formula sheet for you. by the same token, this is also a problem that you can't just go there in one step. If we could, then we would already, there really wouldn't be any point to figuring out how many seconds there are in a week, because you would just automatically know it. But it's not something that me and probably most people keep in their back pocket. This is also something that I can't do just in one step. I can't go directly from a week to a second. So I start to work myself down. I don't want to go bigger. I don't want to go from a week to a month or a year. I want to go smaller, so I can take myself from a week to a day. Think about it. If you want to get rid of weeks, since weeks are up top, you have to put weeks on the bottom. And you can go directly from weeks to days. And then think about what you know. You know that there are 7 days. Oh, scoot. Sorry about that. I said it, but I was writing it wrong. There are 7 days in 1 week. Right here. I'm going to go ahead and cancel out those units. The weeks are gone now. You're sitting at days. I'm not going to stop here. This is what I'm going to refer to as a chain of conversions, because I can't stop until I get to seconds. So I keep going. Think about now, okay, if days are up top, I've got to get rid of days. So I put days on the bottom. I can't go directly from a day to a second, but I could go from a day to an hour. And think about what you know about the conversion factor between an hour and a day. There are 24 hours in 1 day. Now at this point, look at what's canceling out. Days are gone. But still, I'm not going to stop because I'm sitting at hours and I'm trying to get to seconds. I keep going. My chain's getting a little longer here. I want to get rid of these hours since hours are up top. Put it on the bottom to make it diagonal. Again, you probably don't know how many seconds there are in an hour, but you do know how many minutes there are in an hour. There are 60 minutes in 1 hour. Canceling out now the hours. And then I bet we can go one more and be done. Get rid of those minutes. Minutes on the bottom. And you know how many seconds are in a minute. And we know that there are 60 seconds in 1 minute. This is how I know to stop, because now at this point, every single unit has canceled out along the way, and I'm sitting at the end with the unit that I was trying to get, which are seconds. And now at this point, you're putting in your calculator 1 times 7 times 24 times 60 times 60. You should get a large number. 604,800 seconds. If you think about it, that should make sense, that a week, seconds is basically your smallest unit there of measuring time. You should expect a lot of seconds in a full week, okay? All right, I'm going to let you tackle example 5. And with example 6 and example 7, example 6 is actually the easier one than example 7. Both of them have a new element to them where you have more than one unit. Up to this point, you've only had one unit, okay? So I'm going to do example 7 only because it's the harder problem, and then ask you to go back and do example 6, okay? I think that's the better route here. All right, so here's what I mean by, on that last problem, you started with just 1 week. In example 7, you've got a slingshot that is projected at a speed of 5 miles per hour. They want us to find this speed in feet per second. So think about what you're starting with here. You're starting with 5 miles per, back on the front page, told you to divide every 1 hour. I have 1 unit up top and 1 unit on the bottom. That is almost always the case. There's only one case where you have more than 1 unit on the top or bottom, and that'll come up in the next section. But by and large, the vast majority of all of your conversions will always have 1 unit up top and 1 unit on the bottom. So a common mistake I see is folks trying to put both of those units either on the top or both of them on the bottom, and when they do that, they end up getting their conversions in the wrong spot. They divide when they should multiply, or vice versa. So 5 miles per means to divide, I'm putting 1 hour on the bottom. Now what makes this one a little bit harder than example 6 is that this one is asking us to convert these miles per hour into feet per second. So what that means in this problem is I have to get rid of the miles and convert them to feet, and I've also got to get rid of the hours and convert those to seconds. When you get to the next, when you go back and do example 6, you won't have to convert both of the units, okay? You only have to convert one of them. All right, so in example 7 here then, I have my 5 miles up top. So it does not matter which one you want to get rid of. Like if you want to convert your miles to feet first or hours to seconds first, it doesn't matter. I'm going to do the miles to feet, for example, though first. So if I want to get rid of miles, I'm going to put miles on the bottom. And you're looking on your conversion sheet, you can go directly from miles to feet. There are 5,280 feet in 1 mile. Don't get mile confused with meter. Mile is MI, meter is just M. So for this conversion factor, you should be at the top of that conversion sheet. Now at this point, miles cancel out. And I can't stop because I'm sitting at feet per hour. So I'm going to keep on with my chain, but I have at least established that I've got the first part that they asked me for. So now I'm going to try to get rid of these hours. Now think about hours here on the bottom. In order to get rid of hours, they have to be diagonal. So I can't put them down here on the bottom. They've got to be diagonal. So in order to get rid of hours, I've got to put hours up top. And just like you saw in that previous problem, I can't go directly from an hour to a second. I'm going to first take it to an hour to a minute. And we know that there are 60 minutes in every 1 hour. So now hours cancel out. Now at this point, again, I can't stop because think about the units you have left. I've got feet up top and minutes on the bottom. I want seconds on the bottom. So I keep going. To get rid of those minutes, again, minutes are on the bottom. So in order to get rid of them, they have to be diagonal. So that's going to force me to put minutes up top. And I can go from a minute to a second. And we know that there are 60 seconds in 1 minute. Now at this point, minutes cancel out. And also at this point, if you look at it, the only units you have left are feet up top and seconds on the bottom, which is exactly what you wanted. That's your cue that you can stop this conversion chain and multiply straight across. So up top, you're doing 5 times 5280, which should give you 26,400. And then on the bottom, you've got 1 times 1, which is, of course, 1, times 60 times 60. So 60 times 60 should give you 3,600. After you do that division, you should get 7 point, I believe it's 33. Let me double check that. Yeah, 7.33333. Oops, go away. 333. And here I'm asking you to round to the nearest hundredth. The hundredth spot is always the second place after the decimal. So this 3 behind it tells me to keep that 3. So I'm looking at 7.33 feet per second. Final answer. Okay. And like I said, now what I would recommend that you do is go back and pause it and go back to example 6. Example 6 is going to be a little easier because you'll notice here you're starting with kilometers per hour. So you're going to have 1 unit up top and 1 unit on the bottom. But notice it's asking you to convert to miles per hour. So the hours are already taken care of. This time you only need to convert the kilometers to the miles. So that's going to be an easier problem to work through, but nevertheless it still tackles the idea of having to use 2 units and making sure you only put 1 up top and 1 on the bottom. Okay. All right, so then I'm going to scoot on over to the next page. On the next page. And look at example 8 with you. In example 8, it says, well, let's measure the classroom and express its length and width in feet. And suppose then the college wanted to carpet this classroom, how many square feet of carpet would be needed? So, of course, you know, we're all sitting in different places at the moment, so you don't have a classroom to measure. So let's just say, for example, that our classroom is 20 feet by 30 feet. Okay, length and width. If they want to carpet this classroom, then carpet is covering something. That refers to area. Sometimes folks get area and perimeter mixed up. Perimeter would be if I wanted to put molding around the floor or around the walls. Okay, perimeter would be just going around the outside edge. But if you ever want to cover something like you're putting down carpet or putting down some tile or putting down sod or putting on a tablecloth, okay, all of that is covering, so you're referring to area. So, and another cue here that you're talking about areas that ask for square feet. And as I mentioned on the front page of this notes, that square represents that you are looking for area. So area of our room here, length times width. So 20 times 30. And of course that gives you 600. Feet times feet. So you have square feet. So that's our final answer for that part. All right, so here's where you step it up a notch. So now it says at the carpet store, you learn that the carpet is sold in not square feet, but in square yards. They want to know then how many square yards of carpet are you going to need? Start with what you have. You've got 600 square feet. It's not a fraction, so I'm going to make it a fraction by putting it over 1. Now, looking on your conversion sheet, you might notice that you don't have any units that are square. So ignore that for the moment. You ask yourself now, though, can you go just from a regular foot to a yard? And hopefully you would agree that you can, because looking at the top of your formula sheet, 3rd row down, it tells you that there are 3 feet in 1 yard. So again, I'm going to ignore this squared here just for a moment. So if I want to get rid of these feet, I'm going to put feet on the bottom and yards up top. And we know that there are 3 feet in every 1 yard. Here's what we cannot ignore, though, at this point, okay? This is square units. So if that is square, then that means these units have to be squared. Anytime these units are raised to a power, what that means then is that the numbers that you, conversion factors that you pull off your conversion sheet, have to be raised to that same power. So that means this is 3 squared and 1 squared. So again, that's always something I think it's worth reiterating. This is square feet. We don't have a conversion factor on our sheet that tells us, you know, the conversion factor go from square feet to square yards. So what I did is I looked at what can take me from feet to yards and just ignored it for a second. We know that there are 3 feet in 1 yard. Go back though now and look at, okay, these were square units, so anytime you have to square your units, then you've got to square the conversion factors that you pulled off your conversion sheet. At that point now, square feet have canceled out, and the only unit I have left then are square yards. And so I can stop. Up top, you have 600 times 1 squared. If you think about it, 1 squared just means 1 times 1. So that's still just 1. So 1 times 600, 600. On the bottom, this is where it makes a difference. 3 squared is 3 times 3, which is 9. Okay. So then you're throwing in your calculator, 600 divided by 9, and then that should give you 66.6666, and then you'd have like a 7 at the end. And we'll do this rounding, make sure we're tackling this rounding as well. It tells you here to round to the nearest hundredth. So as I mentioned in the last problem, the nearest hundredth is the 2nd place after the decimal. That 6 here behind this 6 tells me to round this number up for a final answer then of 66.67 square yards. Okay. You're definitely going to see this on the test where you have to, if your units are raised to a different power, if they're raised to the 2nd power, then you've got to take those conversion factors and raise them to the 2nd power. If these units are raised to the 3rd power, because if you were doing volume, then you need to raise these to the 3rd power. Highly recommend, take a moment if you need to, replay this part, and then pause the video and try example 9, okay? It's working with volume, so you'll be raising it to the 3rd power, okay? All right, so I'm going to scoot on down then to our metric conversions, which you should hopefully find these to be even more straightforward than the previous ones, because what you're going to notice on these, I'm not going to do anything fancy, it's just going to be a simple decimal movement. But the trick is here, you have to have any of these prefixes in order to be able to do that. So if you don't have these prefixes, then I can't do this simple decimal movement. So it has to involve these prefixes in order to do these decimal movements. There are 3 base units that we'll be looking at: meters, grams, and liters, and it just depends on whether you're measuring a length, a weight, or a capacity. Are you trying to fill something? And then you have deci, centi, and milli, and so that those prefixes can go with a meter, a gram, or a liter. So you have a decimeter, a centigram, a milliliter. On the other side, you go deca, hecto, kilo. So deca, the abbreviation is DA, so sometimes folks will get that confused with deci just being a D. You'll notice this chart and the number line below it, both of these are on your conversion sheet, so it's not something you have to memorize, but nevertheless, sometimes that gets folks. So a decameter, a hectogram, a kiloliter, for example, okay? So if, for example, just to give you an example, suppose I wanted to convert from a liter to a centiliter. If you're sitting at a liter and you want to convert to a centiliter, then you say to yourself, okay, well, I would have to go from a liter to a centiliter, I would have to move two places. So that means then is I would move my decimal two places, and if you'll notice, we went to the right, so that means I moved my decimal two places to the right. Suppose you want to go from a gram to a kilogram. Sitting at the gram, you go 1, 2, 3 places to get to that kilogram, and you move to the left, so I would move my decimal 3 places to the left, okay? All of this is also represented down here in the number line format, so that's from there to there. And you'll notice underneath them, I wrote their scientific notation. So like deca is 10 to the first power, hecta is 10 to the second power, 10 to the third power. That's just a way of noting that they are just increasing by a power of 10. However, here's where I really want to draw your attention. If you'll notice that if you go from milli to micro, you notice here you're just counting down by 1, but when you go from milli to micro, you go from 10 to the negative 3 to 10 to the negative 6. So while you are physically only moving one spot, you are going to be moving your decimal 3 places. Likewise, if you go from micro to nano, you go from to the negative 6 to the negative 9. Again, you're going to be moving that decimal 3 places. Nano to pico, again, another 3 places because it's going from the 9th to the 12th. From here to here, these are just 1 places, right? Because it's going from 1 to 2 and from 2 to 3. And likewise, just 1 place, just 1 place. But when you go from kilo to mega, notice how you go from 10 cubed to 10 to the 6. I'll be moving that decimal. Even though it's physically 1 spot, I'm going to be moving my decimal 3 places. Mega to giga, 3 places. Giga to tera, 3 places. So just be conscious and aware of that, okay? I'm going to do example 10 and 11 with you. In example 10, you've got a 16-ounce Coke. It holds 560 milliliters in the bottle. They want to know how many liters of Coke are in the bottle. So I have this 560 milliliters, and I'm trying to convert that to liters. So this should be, as I mentioned before, a fairly straightforward decimal movement. You can look at it either here in the number line or up here in the table. I think just because my number line's got a lot going on now, I'm going to come up here in my table. If I'm sitting here at a milliliter and I want to get all the way to this liter, then if this is where I'm starting, don't count where you start, count your movement. So you went to a centiliter, so that's 1, deciliter 2, liter 3. And I move to the left. So I'm going to take this decimal and move it 3 places to the left. If you don't have a decimal in your number, hopefully you recall that it's sitting at the end of your number. And I'm going to take it now and move it 1, 2, 3 places to the left. So now I have a final answer here of 0.560 liters. Technically, in this case, that last 0 could be knocked off, and you could just make it 0.56 liters. Whatever you feel more comfortable with, but they're the same. They're the same number. Okay. Zeros at the end of the zeros after a decimal at the end can be dropped. Okay. And then, like I said, I would do example 11 with you. It wants to know how many nanoseconds are in 1 microsecond. So I'm sitting here at 1 microsecond, and I want to convert that to a nanosecond. So with my microsecond going to a nanosecond, notice that I'm here going from micro to nano. I'm moving physically 1 spot, but I'm really going to have to move my decimal 3 places, and since I'm going from micro to nano, I'm going to the right, so I'm going to move my decimal 3 places to the right. So I have my 1 here, my decimal sitting here at the end, and I'm going to go 1, 2, 3 places, and you just insert zeros now. So 1 microsecond is equivalent to 1,000 nanoseconds. Final answer. Okay. I'll let you try example 12, and then we'll scoot on over to our last page. All right, I got out of order there. Last page. Example 13 is just doing your temperature conversions, and that's just using your formulas, and those formulas are on your conversion sheet. So I think you should be good with looking at those formulas, and you're just plugging them in and throwing them in your calculator. So I think you should be good with those by looking at the formula sheet or the solution key with that. So let's move on to I'm going to do what I did last time. Example 14 and 15 are looking at monetary money conversions, but 15 is harder. Okay, so I'm going to do 15 with you and then have you go back and do 14. All right, so looking at example 15, it says while you're in Canada, you rented a car and the price of gas was 1.34 Canadian dollars, that's CAD, it's Canadian dollars, per liter. They want us to figure out, well, what would be the price then in US dollars per gallon? Because as you know, we we pay our gas in dollars per gallon. It's a price per gallon. So this is a good kind of recap for something that we did earlier. Here I have 2 units, right? I have 1.34 Canadian dollars per every 1 liter. So I had 2 units. One's up top, one's on the bottom. I can't emphasize this enough. Anytime you have more than 1 unit, except for that one case that's coming up in the next section, by and large, it's always 1 up top, 1 on the bottom. I'll address that in the next video for you. All right. This is worth looking at on your formula sheet. You're on the second page of the formula sheet. This will sometimes trip folks up, so I'm going to pull this up for you. On the second page there, just underneath the temperature conversions, are your currency monetary conversions. We're going to be looking at this second row here. Here's what you want to always keep in mind. All of these over here in the left-hand column, these are always the ones. So 1 pound is this much US dollars. 1 Canadian dollar is 0.7586 US dollars. So what that means is the US dollars in your conversion always get this value, and the exchange money would always have the 1 associated with it. Okay, so with that said, I'm going to go back to our notes and back here. Just like I mentioned before, you can convert your money first or your liters first. I'm just going to do the one on top. So to get rid of that Canadian money, and I just saw on my conversion sheet that I can go directly from Canadian dollars to US dollars. The 0.7586 is the US equivalent, so that goes up top where I have my US, 0.7586. That 1 Canadian dollar is equal to 0.7586 US dollars. At this point, Canadian dollars have canceled out, and I have US dollars per liter. I'm not going to stop because I want US dollars per gallon. So I keep going. I want to get rid of liters now. Since liters are on the bottom, I've got to put liters up top. You look on your formula sheet and ask yourself, can you go directly from a liter to a gallon? And you can. And it's actually all the way at the very bottom of the front page of your formula sheet. It tells you that every 1 gallon, so my 1's going to be on the bottom, is equal to 3.785 liters. So 3.785 is associated with the liters. My liters are up top, so that's where the 3.785 goes. At that point now, my liters cancel out, and I'm left with US dollars per gallon, so I can stop. And I just multiply straight across, and let me do this so I can show the proper rounding. So you have 1.34 times 0.7586 times 3.785. In your calculator, you should be getting a 3.8475, and you get some more numbers, but that's plenty. Anytime you are doing any kind of money conversion, you're always thinking about dollars and cents. Okay, so when I say round to the nearest cent are your pennies here, and that's your hundredth spot. That 7 behind it tells me to round up, and so now I'm referring to $3.85 per gallon. Final answer. I just converted that Canadian money per liter into US dollars per gallon, okay? They can take a little bit more getting used to. I highly recommend. Sometimes for some folks, you have to play the video from top to bottom again. Sometimes it's really good to hear it twice. And then I can't emphasize enough, just doing the notes isn't going to be enough. Be sure, I highly recommend that at the bottom of the notes, there's a section of homework problems. Work through some of those, even though I'm not collecting them, work through some of those. And then also, there's a lab associated with this section. Go into Blackboard, into Unit 1, click on the labs, and I can't emphasize enough how much that lab is going to help you master this material and be better prepared for the test and the quiz, okay? All right, so thanks a lot.